Let some people trickle in. There we go. There's Joe. There you go. Hey, Joe.
You're here now. Guess I got 1 minute.
What does off stage mean?
Good question. Yeah, yours says off stage.
Well,
Yeah.
he's there. So how did you get your screen to blur, Joe? I wouldn't do that. Oh, there we go. We'll give everyone just a couple minutes to get settled in and joining. So looks like we got a couple jumping on. Bryson, do you have to publish the polls? Yeah.
Yeah, I have them as drafts. You got to publish them.
Perfect.
I can publish them now.
Or afternoon, everybody. A couple more minutes. We'll go ahead and get started, but just getting some people logging in at this point. Should we go ahead and get started, or maybe give people a couple more minutes, maybe till 5 after? We got a couple on so far out of all those that registered, so maybe they're just a little late. So that's what we'll do. We'll give it till 5 after, so just a couple more minutes, 2 more minutes.
had to go to the participants panel and show myself. Now it says I'm on stage.
There you go. Weird. That must be new. It's a little different.
Maybe they just don't want me to talk today.
All right, we'll go ahead and get started here. For those in attendance, there is a chat area and a Q&A area. There's also some polls up, so if you want to jump over there, answer some questions. If you have any questions, I'll be monitoring the chat and the Q&A. So at any point, just jump on in and type in your questions, and we'll do our best to address them. So thanks for being with us today. We'll go ahead and get started. Just as a quick intro, the speakers today are going to be myself, Sean Herring, the Vice President of ProSoft. A little bit about ProSoft. We've been in business now for just over 40 years. We're a strategic partner in the AEC industry, and we offer a wide range of products and services, IT services, Autodesk training, consulting services. And what we're here to talk to you about today on the hardware type side of things. I've got Bryson Anderson, our Director of IT at ProSoft. Bryson, if you want a quick hi and intro.
That's me. Yeah, been with ProSoft 13, 14 years. Been in the IT industry a little over 20 years. Excited to chat with you guys today about hardware and what we do and how we do it.
Awesome. And then we also have Joe Hahn with BIMTM. And I'll turn a couple minutes over to him for a quick intro of himself and who BIMTM is.
Awesome. Thanks, Sean. Yeah, my name is Joe Hahn. I'm the BIM manager at BIMTM. BIMTM is a construction technology BIM consultant. We're 100% US-based BIM team supporting MEP subs and general contractors on all sorts of different stuff. Modeling of elements, clash detection, lead coordination or discoordination on the VDC side. We also do a lot of training and consulting. We have a BIM Accelerate training program that teaches users not just about software, but also BIM and construction processes. So it's pretty cool. And it looks like there will be potentially some BIM Accelerate curriculums in the Expo tab, if anybody wants to check that out. And just as a company, our goal is to deliver models that are actually constructible in the field, that don't cost hours of rework, RFIs, endless headaches, and extra dollars that we're not budgeted for. So we kind of swoop the whole industry and do what we can.
Great. Thanks, Joe. Yeah, and today we're here to really talk about why hardware, why workstations, how to select workstations specifically for the AEC market. So Bryson will talk a little bit about the agenda.
Yeah, so what we're going to do is we're going to kind of walk through the process of how I would go about selecting hardware for the AEC industry. We'll talk about why is AEC industry unique, what software, and what happens that requires a different selection set than, say, if you were in some other industries. And we'll kind of walk through, what does this selection look like? What things do you think about? And basically kind of walk you through step by step, this is how I would pick hardware. This is the hardware I would pick. And then at the end, Joe's going to talk a little bit more about once you've got the hardware picked, how do you make sure that hardware is working really well for you? There's a lot you can do to kind of dial in that hardware and make sure it's working the best possible. So really, first and foremost, why does hardware selection matter? Why does it matter? Why can't you just go to Costco or to Walmart and go pick up a machine? Why do you need to think about what you pick for this industry? So wanted to just kind of talk about a couple of things. One is just the critical role of hardware. How well your hardware performs is going to depend how fast you can model, how fast you can draft. If you're on an underpowered, slow machine, every pick, every click is going to be slow. Everything that you do is going to be hampered by that. And really, this industry has software that takes a lot more processing power than what you would typically see in other industries. You've got rendering and processing applications that'll eat up everything you throw at it. Even your day-to-day Revit, AutoCAD are going to take a lot more to run than what you typically would see. And really, we do a lot in the AEC industry that goes into visualization and making those pretty pictures, 3D models. There's so much that we do in this era of taking what we're constructing and making it visible, making it something that's pretty and spinnable and walk through. And that just takes a lot of processing power. So optimizing your workflow to work on the best hardware, picking the right hardware so that when you go to start working, you're streamlined and working well. Sean, did you want to add anything to AEC and why it matters?
Yeah, if you want to go on the next one there. The biggest thing is the hardest part, I guess, is a lot of people run into is you're overwhelmed with information. You're constantly thrown, this computer is awesome, this computer is awesome. Where do you start? How do you start? How do you make a decision between one or the other? What questions should you ask yourself before buying a new computer, whether that's mobile or a desktop workstation?
Exactly. There's so many factors that go into it. And so we're going to try to simplify that today and really try to ultimately answer 3 questions. Who's the user and what do they do? What software and workflows are they going to utilize? And how do I take that information that I gather and make a decision about hardware? So as we go through today's webinar, we're going to kind of walk you through a fake real world scenario. We've got Bob Jones here, just a fake BIM designer for structural engineer, Acme Consulting Engineers. We're going to, as we step through, use this as an example. At the end, we're going to come up with a suggestion. This is the computer we would pick for Bob. This is why. So as we step through these, we'll talk about kind of a real world scenario. So let me introduce you to Bob Jones, BIM designer for, like I said, Acme Consulting Engineers. He works on large Revit models, does occasional visualizations in Enscape and Lumion, works primarily in the office and occasional field visits. This is a very, very common, the reason that we picked this one is that this is a really common workflow that we see, and a person who does enough with hardware that, the question is what's going to be good for these different things that Bob does. So we're going to answer those 3 questions. Who is the user? What do they do? What software is he using? And make a selection out of it. So really, when it comes down to that first question, who is it and what do they do? That's going to be key, right? Because you have all sorts of different users, and different users are going to do all sorts of different things. On the bottom of this list, you see admin and office staff. So, that's going to be people not in the engineering CAD environment. They're going to need something very different than someone who does your visualizations. Somebody who's in Enscape or Lumion, who's making 3D renderings, or the people who are drafting, who are doing day-to-day drafting. It's going to be a very different set of software that they use, which is going to have a very different hardware requirement. So I kind of broke this out into a couple of different, very common user types. If you can kind of put someone into a user type as you're selecting hardware, you'll have a better idea of, if you say, hey, here's 6 different categories of people, and at your office, you're probably not going to have 6 different categories, but typically the first step is to kind of categorize people so you can say, if they fit in this box, let's get this type of computer. So drafters and designers, your production staff, your people in Revit, your people in AutoCAD, those day-to-day need heavy modeling computers. BIM coordinators and managers will do some of that, right? They're going to be doing some clash detection. They will be doing some markup. They might be lightly in the models, but not day-to-day. You got visualization specialists, people who are going to be focusing more on the Lumion, the Enscape, the Blender. There's 100 of them out there. Different applications that are going to create that pretty picture. Processors. People were taking drone imagery and using Pix 4D, using Cyclone, using whatever to take that data, make it usable. You've also got field people, on-site users. And what we see a lot is, you might have someone who is a coordinator manager who also does on-site work. And how do you address that with the hardware they've got? So as you talk about the different user profiles and what they do, there's a couple really unique scenarios that come up with AEC software. First and foremost is the single-threaded applications. So what we're talking about in a CPU, kind of the heart of the computer, you have different ways that programs utilize a processor. A processor, as I'm sure you know, has multiple cores, and those cores have different speeds. And different type of applications will utilize that CPU difference. So single-threaded applications, AutoCAD, Civil 3D, and honestly, even a good majority of Revit is single-threaded, meaning it's only going to use one core at a time. And so if you throw a CPU at it that has a lot of cores, but they're slow, so like think Xeons. I see a lot of people using Intel Xeon processors. They're geared more towards the rendering, processing, and server line. But people will put them in place and use them for AutoCAD and honestly actually hamper themselves on what is a great machine, just not well fitted because it's a multi-threaded type of computer that would be great for like 3ds Max, Blender, things that are doing CPU render that will use multiple cores. Visualizations and point clouds take a whole different set of CPU, GPU, RAM. We'll kind of dive more into specific softwares on those. And then you got a lot of hybrid workflows. I see a lot where somebody is a Revit designer and they're in Revit designing, modeling 80% of the time, but they're the one that is in charge of visualizations. So they do, a little bit of Lumion, they do a little bit of Enscape. They do something that needs to support both. They've got a hybrid workflow that needs to support both rendering and Revit. Revit's got some really interesting requirements. It's partially single-threaded, partially multi-threaded. It will also just eat the crap out of RAM. So Autodesk suggests with Revit that you have 20 times the central model size in RAM. So let's think about that for a second. If you have a 2 gig Revit model, which in today's world, a 2 gig Revit model is not that out of the question, see it all the time, you should have 40 gigs of RAM. So kind of think about that in models that you work on. If you've got, and also don't forget your links. So if you've got the architect's model and it's 2 gigs and MEP model is 2 gigs and you've got, cumulative 8 gigs, how much RAM could you need? That's 160 gigs of RAM. Usually what we see is on the larger end, people don't typically have enough RAM for what Autodesk suggests. Doesn't mean it's not going to work. But the short of it is that Revit will eat up just about everything you throw at it as your models get larger. So RAM requirements are going to be a lot higher there. So let's kind of dive into some of those individual softwares. So we talked about AutoCAD. AutoCAD, it's a little bit older application. It was built many, many years ago, and it was built completely on a single-threaded platform. It does no multi-threading really to be seen at all. It's going to lightly use a GPU, but not going to hit it heavy. You're going to see moderate RAM usage. So as we take that profile of who are they and what software do they use, a list like this is going to be really good to kind of reference back to and see, okay, they're doing AutoCAD, they're doing Civil 3D. How's that going to be a little different? Well, Civil 3D, you're going to use a little more CPU, especially if you have large aerial imagery. We see that a ton. That Civil 3D, though it's built on AutoCAD, is going to have some unique demands on things like large aerial images that are going to eat up way more processing power, RAM, everything, than, say, a 2D AutoCAD of a house that's being designed. Revit, I feel like Revit in every discussion is always the unique platform and runs in unique ways. And that is not, that's the case when it comes to picking its hardware. So it does a mix of single and multi-threaded. So it will take advantage of fast cores and many cores depending on what you're doing. You do have a lot of 3D stuff that you do when you're spinning, orbiting, moving, navigating through a Revit model. You're going to have some heavier GPU use. There is some rendering you can do inside Revit. But then if you're working on 2D sheets, you're going to be all single-threaded. So there's really a balance to be found there. Same thing when you get into like Rhino, Grasshopper, you're going to see a mixed workload where it's going to use some single, some multi-threaded, GPU, RAM. Navisworks is going to be very visual. You're going to have a lot more on the GPU. Twinmotion, Enscape, Lumion, those are going to be really heavy on graphics. And this is where it starts to really get unique because there's different types of graphics, and we'll dive deeper into each individual type of component and what I'm talking about when I say there's different types of GPUs. But that type of software wants very different processing because it's more game-like. And in fact, like Twinmotion is using a gaming engine in the background to make those renders, to make those pretty pictures. 3ds Max, Blender, V-Ray, Arnold, you can do CPU and GPU rendering, or both at the same time. Point cloud and processing is going to use up CPU, GPU, and RAM, everything you throw at it. So really, as we take those different types of users and the software that they use and bring it all together, if you're a drafter and designer, you're going to be in probably Revit, AutoCAD, Civil 3D, and we're going to want to make sure that we have a CPU it's high clock. We're also going to want to make sure we have enough RAM and some decent graphics. We don't need to go crazy with graphics unless we're doing some rendering, we're throwing some visualization tasks at it. Then we're going to want to also bolster the GPU. So there's always this balancing act of who is it and what are they doing, and what do we need to put behind them to make that possible. And sometimes you have to make some sacrifices and some choices. So let's kind of break each important component. We're going to break 5 computer components down and talk really in depth about why you would select what and for what workflow. Sean or Joe, do you have anything to add about user profiles or specific softwares?
Not really. I think that's a good, other than I think that's a good way to kind of differentiate the different people that work at your firm and the different roles and responsibilities they have within kind of the whole design, engineering, construction process. I think what Bryson was kind of getting at is that, you know, there's different roles within the industry, and they all have sometimes slightly, sometimes more than slightly different needs. So you just kind of got to know about that and account for it, basically.
And Bryson's alluded to this a couple times on the point clouds, for example. You could identify your surveyor or survey division, you know, as this is their use case, this is the computer need, but not all surveyors are created equal. Some surveyors may just be Civil 3D and Civil 3D only, but as Bryson's mentioned a couple times, you start introducing those heavy processing tools, Pix4D, Cyclone, you know, you name it, you know, that changes that surveyor typical machine into something that is a much greater need. And that goes the same thing for Revit designers or anybody, but there's a lot of aspects there depending on their workflow in helping to identify that.
Definitely. What you'll often find is whenever we have these discussions, typically it's going to be a very similar discussion to kind of what I've been talking about here is, all right, tell me about, you know, you need a computer for Bob, tell me about what he does. And we'll dive in, and you'll often find that more goes on than what you knew about. Well, he's a surveyor, he's in Civil 3D, but oh, did we also know that when he's bringing in drone imagery that he's stitching those on his own machine? Did we know that, you know, he's got requirements for maybe he needs to be mobile and needs to do some on-site work. And so mobility, we didn't realize was part of this and need to include that. So kind of diving through who it is and what they do is really the first step that I do with any, hey, what computer should I buy discussion, is really identifying what are the workflows, what are the software, and then talk through some of those unique pieces, because some of them are quite unique. What I see a lot, this is a use case I see all the time, is a Revit user who moderately does some other piece in here, right? They're doing a little bit of Twinmotion, they're doing a little bit of Max, they're doing some other piece with it. And a hybrid workflow, nobody really ever fits into the same exact, you know, this is all I do. You'll have the occasional, all I do is day-to-day Revit, and that's all we need to account for. But really understanding what is it end-to-end that they're doing. And of course, there's way more than the AEC applications, right? They're going to be in a web browser, they're going to have Outlook, they're going to do Adobe. And most of that stuff is going to be light enough that whatever decision you make on this side, let's make sure it's a good Revit machine. That's going to be a great machine for some of the simpler apps. So what we're focused on here is the AEC apps, and specifically so because everything else will kind of fall in line beyond this. You might find some unique scenarios where they have something that maybe doesn't fit an AEC application that requires some decent workload. A common one, and it's usually on the admin machines, or maybe you've got an interiors department and they do a lot with the Adobe products. So you've got Acrobat, Illustrator, Photoshop, all that. Those will require kind of more in that Twinmotion, Enscape, Lumion scenario type of computer. So really what I look at is what's the heaviest, and then whatever you build out for the heaviest is going to certainly serve some of the lighter applications. All right, so let's kind of dive into each type of component here. We're going to start with the CPU and discuss some of the ins and outs, intricacies, and why I would pick what. So we talked about earlier multi-core, single core. For those of you that don't know, a CPU is kind of the heart, brain of the operation. It's what does most of the processing. And it has multiple cores. So many, many years ago, there was only one core and you had one speed across the CPU. That's changed. You now have it's not uncommon to have cores in the 20s and even into 30s. But each of those cores can do a task. So you have multiple cores so that you can handle multiple tasks at once. And the clock speed is how you identify how fast each of those cores are. And you have CPUs that really are on either end of this spectrum. So you'll have like Xeon processors that are meant for servers that don't have large tasks, but they have a lot of tasks. And so for that, you'll have a 32, 40, or sometimes even multiple physical CPUs with multiple cores. Because what you're trying to address is a whole bunch of tasks that all need a little bit of processing power all at once. It's a great CPU for that specific scenario. But if you are a CAD designer, you can only take advantage of one of those cores at a time. If you have one of those CPUs that's a slower clock speed, it's say 3 gigahertz, versus one that would be good for AutoCAD that's 5 to 6 gigahertz, you'll see that you have, even though you've got a really good CPU, you're only getting half the processing power for AutoCAD. So you have kind of these two different avenues, if you will. Are we being really good for multi? Are we being really good for single? And then, of course, the more common scenario of in the middle, I do a little bit of both. Revit's one of those ones that's a little bit of both. More and more things are going multi-threaded in Revit, which means, like when you are pan, zoom, tilt, when you're rotating a 3D model around, that will use multiple cores. But if you're in a 2D sheet and you're in, playing with properties, you're going to be just single threaded. So getting a CPU that kind of meets both, it's got a significant amount of cores that you can multitask, but yet still has really fast cores is what we're looking for. So when does the core count matter? That's going to be more on your rendering, analysis, point cloud processing. Your stuff that's not day-to-day drawing, that's going to be more on it's doing some sort of processing. So a couple examples like Pix4D, Cyclone, more on the visualization side. We've talked about it a bunch, but Twinmotion, Lumion, Enscape, all of those are going to use multiple cores to do their tasks. And that's where you'll see a little bit more benefit from having many, many cores. The AutoCADs, the Revits, the design software, the Bluebeams, those are going to use more of the high clock speed. So whenever I'm speccing out a user workstation that is meant for CAD, meant for day-to-day design modeling, I'm going to be leaning towards Intel Core Ultras. If you follow the Intel naming, these used to be Intel Core i5, i7, i9. 2 generations ago, they kind of rebranded to this Intel Core Ultra and did some things with cores. You probably noticed if you look at cores, now you have performance cores and you have processing cores. And what it all shakes out to is if you pick something in that Intel Core Ultra 579, you're going to have one of those good kind of in between. We'll do both single threaded and multi-threaded in each of those. So in the Core Ultra 5, 7, and 9, you have different lines, different models within that line. So for example, an Intel Core Ultra 9 285K, that's kind of the highest end of this spectrum of CPUs, is going to have 24 cores, and it's also going to have everything that's 5.8 gigahertz. So you get that really good mix of, you got a lot of cores, but you've also got some really good speed. There's also some 9s that kind of reduce core count, but also keep that clock speed high. There's also a lot of AMD solutions. They make some great CPUs that fit in the same category. For this specific scenario for Bob Jones, I would pick a Core Ultra 9. Reason I'm picking an Ultra 9 over, say, a 7 or 5 is we identified earlier that he does, heavy Revit usage. He's in large models. He's probably doing a little bit of CAD work. I'm sure he's getting some CAD files he's got to route in. So we want that high clock speed, but we also want it to support multiple cores because he's also doing some visualization. He's going to be doing a little bit of Lumion landscape, and he's going to benefit from those multiple cores. So for him, we're picking that Ultra 9. Next is going to be the GPU, right? So this is the graphics processing unit. This is the piece that makes the pretty pictures. There's a lot of selections here as well. In fact, probably more so than on the CPU. You have a lot of options. And this is where things get a little trickier to figure out, okay, where are we going to lean towards? Because real-time renderers, so the things that create the pictures, things that feel more video game-like, as you'd imagine, are going to work better with a video game style card. So cards that are meant for high frame rate, putting out real-time images, those are going to benefit more. In fact, some of those will say we don't support the Pro line of cards at all. You've got to have one of these gaming, commercial, consumer type cards. This is what you need. This is what works best for our application. And on the other end of it, you're going to have engineering apps that say, no, we support and we want you to have a Pro card. And if you do both, you're kind of stuck in this, well, what am I picking? So when it comes to video cards, you kind of have two different avenues, two different types of cards. Workstation GPUs. On the NVIDIA side, these have been historically called Quadro cards. And on the consumer GPU side, GeForce. That's been their historical name. There's been a little bit of naming shakeup. The current edition of the workstation GPUs is NVIDIA RTX Pro. And then you always see a weird name after it. The current generation is called Blackwell, just the friendly name for the latest generation. You'll see like Autodesk software is certified to work with those cards. They're going to have certified drivers. What sets them apart is they're going to have ECC memory. They are meant for a constant usage. They've got a little bit more longevity built into them, a little bit more robust parts. And they're kind of geared more towards daily in-out use, engineering workflows, calculating numbers, running processes that do more of calculation versus the consumer GPU card, which is going to do more of your create the picture, prioritize those frame rates, make the real-time images. You're going to physically also see a large difference between the two. So a workstation GPU will be a third, a quarter, a fifth the size. The actual chips themselves are about the same size, but you're going to see far higher cooling on those consumer GPUs. So let's talk about kind of the Autodesk side. Let's pick Revit, for example. If you go and you look at Autodesk certified cards, what do you Autodesk certify to work in Revit? They're going to tell you, you need a workstation GPU, you need an NVIDIA RTX Pro card. That's what we certify, and that's what's going to work. They're not wrong. That's going to work fantastic. You will, however, as you can imagine, pay more on the workstation side. If you take a workstation card and a consumer card that score about the same, that have about the same amount of processing power, you'll pay somewhere around 1.5 times for that workstation card. That comes down to a lot of things. Some of it is the politics of it of, well, they've certified it to work. They've got drivers that Autodesk and NVIDIA have built together. Sometimes supports for different software companies will say, hey, we'll only support errors and crashes and help you if you've got these certified cards. And 10, 15 years ago, I would have agreed and said, look, stick to a workstation card. If you're doing Revit, you really got to have that NVIDIA RTX Pro card. Over the last 10-ish years, things have changed quite a bit in that arena. Autodesk still does not officially support GeForce cards. We use hundreds, thousands of them a year without issue. They work great with the Autodesk stuff. True, they are not certified. And so for some, they say, no, look, I want to make sure I'm certified by Autodesk. I don't ever want to run into an issue. A workstation card is going to be great. What you'll run into is the occasional, if it's a hybrid computer where you're doing some of those visualization workflows, you're doing some of the Revit workflows on the same computer. Revit's going to work just fine on the GeForce card, but some of these other apps are going to throw a fit at you and say, hey, this is not a card that we can use. We can't do this. You need to get a different card in place. So in a hybrid workflow, almost always my suggestion is go with an RTX card. One of the other benefits of the GeForce RTX is you get a much larger cooler. So for example, we were putting together a computer the other day that had a 5080 in it, and all just drooling over the size of the cooler on this. The size of the chip is, this little thing the size of a pack of cards, and the cooler is 18 inches long and 3 inches thick. They have much, much higher cooling capacity on those cards than you do on the workstation GPUs. If you're doing processing, if you're doing visualizations, I'm going to lean you that direction. Even for your typical Revit machine, you just get so much more bang for your buck out of a GeForce RTX card. So when it comes down to it, you really can't make a wrong decision necessarily on which you pick. If you want to make sure you're certified, you want to make sure it works perfect with the Autodesk stuff, go that NVIDIA RTX Pro route. If you want kind of a mixed use card, you want to get the most bang for your buck, go with that GeForce RTX. I'll tell you, in the last few years, I can't think of a single time that I have seen an issue in Revit caused by a GeForce card over a Pro card. 10 years ago, that was a different answer. We'd see some weird anomalies. We'd see weird line work that didn't exist in CAD. You saw a lot more issues. Joe, have you seen on your end any issues for people using RTX cards in Revit?
I don't think so. I would probably agree with what you said, that especially lately, no, definitely no. Maybe 10 years ago or further, you'd get kind of those weird things where, like you said, a line would show up in the wrong place, or your modeled content is just like off kilter or whatever, But lately, no, I haven't seen really any in quite a while, actually.
Yeah, and that's pretty typical across the hundreds, thousands of people we talk to. It's just not an issue like it used to be. So when would you use that workstation GPU? Like we talked about, if you really want that certified driver, they say there's longer longevity on those cards. And I'm not sure I buy into that. But there are some certain applications that you'll run into, load calculation softwares that will say, I want that Quadro card, I want that at pro level card. If that's the case, you'll have to kind of make that decision of, what does this person do? Do they do more of that stuff, or do they do more of visualization? Where do we want to prioritize? A good general card is going to be the RTX 5070. That's what I'm going to recommend for Bob in his workflow. He does those visualization apps, still works in Revit and does some of those things. So I'm going to recommend the 5070. That's the GPU I would select for him. Again, there is a large variety of cards. NVIDIA and AMD are your two big card builders. I for a long time have preferred the NVIDIA cards. AMD makes some decent cards, and there's cards to be had in that arena. But my favorite is the current gen 50 series NVIDIA GeForce cards. And then, of course, the RTX Pro Blackwell line, the 2000, the RTX Pro 2000 is a really great kind of little above entry level, but mid-range good Revit card. The RTX Pro Blackwell 4000 is going to be even a step up from that if you've got a little bit more complex workflows. So that's kind of some in-depth on GPU. Next, let's talk about RAM. So RAM is one that I am of the opinion that you can really never have too much RAM. There is always a task that will spin up that will eat it all. So I would recommend, as a baseline for any machine that's going to touch CAD, BIM, AEC workflows in any way, shape, or form, 32 gigs of RAM. Now, if you have an admin machine, you've got someone who just does a browser and Outlook and Word and Excel and whatever, 16 gigs may be just fine. Nothing below that. You still will in 2026 see computers out there for sale with 8 gigs of RAM. Is just not enough for really any workflow. So sticking primarily to the CAD BIM workflow, absolute minimum of 32. If they are a Revit user that does really any amount of heavy Revit usage, I'm going to suggest you bump that to 64. 64 kind of feels like the new baseline. And what you're going to see is, if you go to really any manufacturer, Autodesk included, you go to their website and you say, tell me, system specs. What do I need to run this application? you're going to get much lower specs than what in real world is going to actually be good for what you're going to do. So, for example, if you went and looked, and Autodesk is getting better at it, but you went and looked at system specs, it's going to say that you need somewhere between 16 and 32 gigs of RAM for Revit, and that's just going to be so underpowered. Like I was saying, Autodesk does a little bit better job. They now do 2 to 3. They'll say for basic usage this, for moderate usage this, and for high usage this. And if you look at that high usage, that's going to give you a decent benchmark for what you need. But these are my recommendations is if it's a regular CAD user, maybe a Civil 3D user, 32 gigs is great. Really lean towards 64 as your new baseline for anything Revit or higher. And then in Revit, if you remember, we talked about how much Revit models can eat when it comes to RAM. If you have 6 to 8 gigs of federated Revit models, which is not that crazy to think about, you have a model with, say, 3 links, and they're 2 gigs apiece. Well, there went 8 gigs of Revit models, and that could eat up 128 gigs of RAM. So we do, in our systems, we often, probably our most popular upgrade is 64 gigs to 128 gigs of RAM. 128 kind of feels like 64 is the new baseline, and 128 is that sweet spot where you're going to have plenty of RAM for now and even really into the foreseeable future. We're also doing a decent amount of systems that do, in these latest systems, you can do either 192 gigs or 256 gigs. We're starting to see more people selecting that simply for they're doing large Revit models. I'm seeing Revit models blow to huge sizes. I saw it was linear rail, and it was a Revit model. When he told me the size, I said, prove it, because I didn't believe it. A single Revit model was like 28 gigs. Joe, what's the biggest Revit model you've ever seen?
Holy moly, not 28. Is that a real number?
Sean can attest that is a real number.
Yeah.
Wow. Okay, I got questions for you guys after this is over about that. What's the biggest one that I've ever seen?
Because I want them to prove it.
Probably 5 to 6 personally.
Yeah, that's more real world.
We don't get super nuts with building design going that big. In historically, even Autodesk would suggest that once you start getting up to a certain size threshold, I don't know what that is in today's world, I guess, since you just said 28, recalibrating what I think about this. But
no, it's at 5 to 6 gigs.
Yeah, it's even when you get that high, they talk about breaking it out by discipline and having literally separate models for different areas so that you're not, hogging every single available resource possible.
To this point, Bryson, because Jared in the Q&A brought up a good question here. I'm sure we'll talk a little bit about this later, but what do you see from a cost standpoint for some of the hardware, especially when it comes to data centers? I know pricing's been affected across the board with most of the components, but I think at this point with the RAM, this is probably the most widely affected cost and the biggest swing.
Absolutely.
Cost. So I don't know if we're going to talk about that later, but that's something that Jared brought up, and this is maybe a good spot to address it.
Yeah. No, we've got a spot. We'll talk about it in kind of the future proofing and where to put the money. But let's kind of bring that in, because you're exactly right. This is the perfect spot to bring it up, because RAM has been affected by and large the most, though when you affect any chip, it's going to trickle down to others, especially RAM, because RAM is used on GPUs. So graphics processors, video cards have RAM on them. So when regular RAM goes up, as do video cards. If you haven't followed the market trends over the last 6 months, but man, even the last 3 months, really, there's been some skyrocketing costs happening with RAM. RAM is more or less tripled in price in the last 3 to 6 months, primarily due to AI demand. AI has large demands for RAM. They can throw as much RAM as they want at it and still need more. And so I'm not sure what spurred this along in the last quarter or two, but basically data centers said, hey, we need all the RAM that we can possibly get, and went to RAM manufacturers and said, we would like to purchase all the RAM that you can possibly give us. What it reminds me of, if any of you are Parks and Recs fans, is Ron Swanson asking for all the eggs and bacon they have, and then correcting and saying, no, I think what you heard was I want a lot of eggs and bacon. I want all your eggs and bacon. That's more or less what these data centers did to RAM manufacturers. That said, We want all your eggs in bacon. So Micron, one of 3 big RAM manufacturers, said, great, well, if we can sell all our eggs in bacon to you, and we don't have to sell it to a million different consumers, we'll do that. So Micron's actually pulling out of the consumer Revit market. It's caused a huge swing in supply and demand and caused RAM to just go outrageously priced. So yeah, that's going to be one piece that as we get into like, where do you decide to put the money? What do you pick first? RAM is certainly going to be part of that discussion because the cost to do a 256 gig RAM upgrade went from 6 months ago. That was a little add-on to doubling the cost of the machine now. So there's definitely a lot to consider with that. And hopefully this is a short-term problem, but I guess time will tell on how long we see elevated RAM prices. But just like with AI workflows, Revit workflows will eat up basically all the RAM that you throw at it.
Awesome. So Bob gets 128.
So Bob's going to get 128. He does these large Revit models, does a lot of multitasking. He's doing visualization stuff. So we've decided that for him, it's worth it to jump up to that 64 to 128 gig upgrade. Well, at the very end, I've got some slides on where to kind of put your money, what to think about. We'll dive more into maybe why we put it here and not elsewhere. All right, moving on from RAM. Let's chat about storage. So storage is a piece that you'll probably notice we haven't really talked a lot about throughout this whole thing because it's one that's not necessarily unique because this is going to be the case across every platform, software, anything that you do. The faster the access you have to your data, the better. So that's going to everything from how fast your web browser opens to how fast Revit responds is going to be affected by drive speed. So old days, those old spinning hard disks, they're still in place on servers. We still use them for large data sets in places. By and large, you do not want that as your primary drive in your computer, and you have not wanted that in your computer for 10 or more years. So I'm sure you've heard about SSDs, solid state drives. That's kind of the way of the future. Unfortunately, this is another category that's been affected by price increases. So the cost of SSDs is come near double in the last 3 months. But really, for any workflow across the board, this is one you don't even really have to break it out by user type. You want as fast access to files as possible. In today's world, that's NVMe M.2 SSDs. You'll see in my little image over here, that one that says M.2 on it. It's hard to get a scale there, but it's literally about the size of a gum stick. Like a little stick of Wrigley's gum, that's about what an M.2 looks like, about that thick, and they're 40 millimeters wide and 150 millimeters long. Little tiny things that hold a lot of data, and they're very, very quick. So in the world of SSDs, when you see like this computer has an SSD, there's a lot of variance in what that means. So you have SATA, old style SSDs that are going to have a read and write of around 500 megabytes a second to new M.2s that are going to have 8,000. So even in the world of SSD, you have a wide variance in speed. You really want the fastest you can possibly get because the faster that data can pull from the drive, the faster it can load, open, save, whatever. So you like I said, you want the fastest as possible. The next piece of that is how much can it store? In the world of Autodesk, up until probably 3, 4, 5 years ago, I would say 512 gig was kind of the standard. That was enough. You could get by. That's really become 1 terabyte, especially if you are an engineer that uses Revit. And I specifically call out engineers because architects seem to have far less versions of Revit installed because they get to pick what versions of Revit they're using. Engineers who work with many, many different architects have everything from 17 to 26 installed. So particularly for engineers, 1 terabyte is the minimum I would go on an SSD, simply because if you need Revit 21 through 26, each one of those is 20 some odd gigs a piece. If you're doing cloud workflows, so if you're doing stuff with BIM 360, with the Autodesk Construction Cloud, you're opening those Revit models, you're pulling locals. Same thing though if you're working from a local server. When you're working in Revit, you're pulling locals. So you're taking copies of those 2, 3, 4 gig models and bringing them local. All of this to say, Revit will eat up a lot of disk space quickly. Those with 512 gig SSDs, we are commonly finding in today's world are constantly running out of space. So I always say go with a terabyte minimum. Anything smaller than that is really just too small. We come across workflows occasionally, like people who process point cloud, render, whatever, who need to have a lot of scratch space. And by scratch space, I mean temporary space. They go and fly with a drone and they bring back 100 gigs, but then their end product is 1 gig. But you need a place to put all of that space. Having those slower data drives, having a spinning disk in there that's 20 terabytes is sometimes necessary, simply because storage over about 4 terabytes in an SSD they do make 8 terabytes. They're wildly expensive. So you occasionally may need some of that slower storage space, but don't install your applications to there. Don't keep your Revit models. Don't install the OS, all of that. Keep all of that on as fast a drives as possible, and go with a terabyte minimum. For Bob, we're going to go with a 2 terabyte. He installs a lot of stuff. Remember, he's a structural engineer, so he's got Revit 17 through 26 installed. He's doing a lot of cloud stuff. He's doing visualization stuff, so we gave him a 2 terabyte.
Sweet.
Can I add one quick thing to that, Bryson?
Absolutely.
Yeah, I think you kind of alluded to it too, but especially on the design engineering side of things, your comment about architects was really funny. I didn't really think about it from that perspective, but that's really true. And the thing that I found, I've worked for just about every type of engineer you can think of. And when you work for a company and you go and you are hired by architects or somebody else to be a part of that project. So my point is that you're working on 3, 4, 5, 6 different projects at the same time, and they're all hosted in ACC. Your hard drive is going to fill up in about 4 seconds as you go through and open those files up, and it downloads all the links and it makes copies of everything. And that's just the one example. Autodesk likes to hide things on your C drive and not really tell you about it, but a lot of it you can delete. So yeah. I have seen one user in particular comes to mind whenever I think about this, because they had a laptop for a couple of years, filled up their hard drive, couldn't figure out what was going on, and we got into the collaboration cache and deleted 467 gigabytes of Revit files. Many of which you can safely assume they had not accessed in literally years. So
yeah,
it gets wild.
Definitely. So kind of the last piece putting this all together is your form factor, desktop versus laptop. Did anybody answer that in the polls? Nope.
Yeah, it looks like it's kind of split-ish, 60-40 laptop.
Yeah, that feels about right. So there's obviously trade-offs. When you've got a desktop in the office, it's stuck there in the office. It's not mobile, and sometimes you need to be mobile. But what you do get is you're going to get more bang for your buck out of your desktop. You're going to get, like, if you look at, say, a video card, a 5070 in a desktop, it's larger than the entirety of a laptop, right? If you look at its overall form factor, it's huge. You can't get that level of cooling, that level of processing power out of a laptop. So even if you take like a laptop 5070 and a desktop 5070, you're getting way more performance out of that desktop, especially if you're doing those visualization things. I always recommend don't do processing, rendering, visualizations on a laptop. Do it on a desktop. We see, maybe you have a dedicated desktop that you do that on. There's a Viz computer or two that people remotely control and do the visualization stuff. It's very hard on a laptop to have it at its thermal max all day, every day. It just wears everything out. They can only cool so well. So my recommendation is, if you need to be mobile, get a laptop. If you want the most bang for the buck, you want the most powerful system, you want to do some of that local stuff, get a desktop. There's a lot that can be done from a desktop that you're not sitting at. So a couple workflows there. One, like I said, you have maybe a Viz computer or 2 or 3 that's a shared, everyone has laptops, but you have some shared desktops that sit back in your server closet or somewhere, and you remotely access them and you run Lumion and Enscape and you do those tasks on that computer, not on your laptop. Common workflow we also see too is a lot of engineers have a really powerful desktop in the office, so that when they're sitting in the office where they're at 90% of the time, they have the best and the most capable machine. And then we're out in the field and they need to go out and do site visits, whatever. They've got a lightweight laptop. Maybe it's a Surface or a HP ProBook or whatever, just some laptop that's far lighter weight And if they need to do something that takes processing power, they remotely control their computer back at the office. So for Bob, that's what we're going to recommend. He does those rendering tasks, works mostly in the office. Get a desktop. If you want to connect from home, from a job site, from wherever, do it with a lightweight laptop and connect in and control your desktop. You'll have a lot better experience that way. Though for some, if you are primarily mobile and you don't really do renderings, but you're a heavy Revit user, but you do it from home, from the office, from wherever, there are some really, really great laptop options. So to kind of sum up everything that we just decided on for Bob, we need a Core Ultra 9 CPU, a 5070. We decided to go to that 128 gigs and a 2 terabyte. So we're going to kind of bump him up on a couple things. What we would recommend for him is a ProSoft Eclipse Arc 9S2. This is kind of our spec'd out system for this exact type of scenario. A heavy Revit user, someone who maybe also does a little bit of other rendering and processing with it. What you're looking at here is the default config on this computer. This is one we'll talk a little bit more. Sean will tell you about some of our in-house offerings here in just a minute, but this is the device that I'm going to recommend for Bob Jones. Sean, do you want to take a minute on ProSoft hardware and where this fits in? And let me give you this other slide here.
Yeah, so as Bryson's alluded to, and kind of as we talked at the beginning, we are AEC people. We build computers and spec them out for AEC people. We're hardcore focused on that, desktops and mobile. The ProSoft brand of computers is the Eclipse line that comes in the Arc 5, 7, and 9. We've got a newer computer that is more kind of the light CAD office admin type that we call the V200. But those desktop solutions have served us well for, pushing 20 years at this point. They all come with a 3-year warranty. We spec them all out. We test them all out prior to shipment. So we've got a solid line of those machines, and those machines can be taken anywhere. We've built machines from that kind of start with that Arc 9 base and, just kind of go up from there. Go back to that last one, Bryson. As far as mobile solutions, we are an HP and a Lenovo dealer as well. I prefer the HP myself. We've got a lot of really good results with the HP, the ZBooks, EliteBooks, ProBooks. I run some pretty heavy models, and I run those on, Bryson could tell me better, but historically the ZBooks and Fury or Power, whatever they're called today. And then we've got some other HP solutions as far as mini desktop solutions, and as I mentioned, laptops. So we've got a pretty good catalog. Those can all be found on our website, prosoftnet.com, or by just simply reaching out to us at any point in time. And we'll probably ask a few questions that we've gone over today to best fit you there. But a lot of solutions for a lot of different products and use cases.
Definitely. I would just echo that with, we do a lot, like Sean said, we eat, breathe, sleep the AEC industry, so we know exactly what it takes. If you call us up and say, I use this app, that app, we'll ask you a lot of the questions that we talked about today. We'll give you a recommendation. We put together some really great hardware. We do a lot of QA, QC testing before it leaves our office to make sure that when it lands at your desk, it's ready to go, not going to have any issues. If it does, we got a 3-year warranty. We can also, we do a lot of imaging and pre-installation. So if you want us to, help you kind of save some time and you want us to get this even more ready, you want to have Revit and CAD and whatever loaded on it, we got all kinds of solutions for you to get it anywhere from here is a machine like you'd buy off the shelf all the way through, we do onboarding services and what have you to deliver a machine that's completely ready to go. Also, like Sean said, HP, we've got everything that HP lineup. Sean, you use an HP ZBook X. It's a new name for the ZBook Power. In fact, we all internally run that. Really, really good solutions. In fact, Sean does a lot of the things I told you not to do, render and process. And even that, it handles it great. Handles it awesome. So even though we recommend not doing it, they'll handle it great. There's some really, really good solutions. Sean,
Awesome.
go ahead.
Sorry, go ahead.
No, so if you want to grab this on the promotion.
Yeah. Before we turn some time over to Joe and Bryce to talk about a little future proofing and why, we do have a promo going for this, for the largest promo that we put out. if you're on the webinar, if you're viewing this webinar, and you either use on our website or give us a call, or BIMTM or ProSoft, either way, we'll extend this 10% out, and it's just a BIM 10 code. 10% is pretty steep discount that we typically don't do, but we thought we'd roll something out special for the people that have taken the time to sit in on this webinar. And yeah, we'll keep that going for a while. So if you do have questions and you're viewing this, you're seeing this, let's save you a few bucks.
Perfect. So the last thing I wanted to just touch on real quick is kind of future proofing as you're picking this. You know, where do you decide to put money? Some of the things, you know, we get asked all the time is like, all right, so here's the Arc9. Where would you upgrade it? If you were to pick one upgrade, what would you do and why would you do it? So a couple of quick things on that. There are some things that are easily upgradable later, and some of the unupgradable later items, you'd be better served to get those put in place in the beginning. So for example, like a CPU or a GPU, if you want to upgrade that to a larger one later, you have to basically just throw the one out that you have and put a new one in. RAM is a place where you can typically add to later. Caveat to that is you got to have space. There's typically 4 slots for RAM. And so if you do, say, a 64 gig in an Arc9 from us, it's going to have 2 of those slots filled with 64 gig. If you wanted to upgrade later, you just simply add 2 more. You can also at any time add more SSDs. So if you needed some more space, you can always add another SSD. So I always start there. You know, is there a piece that you want to upgrade that you can't do later, or that's a throwaway later item? The next thing to look at is, what is it I'm going to do most, and what's going to be the heaviest, and let's try to address that. So for example, if we say, hey, you know, I work in Revit, but I also, man, I do these large renderings, and those are bogging me down. Those are really my biggest pain point right now. Okay, well, let's look at your current machine and where are you lacking. If it's RAM, you know, you tell me, hey, I do this really heavy stuff, and I say, yeah, you're going to use a lot of RAM doing that. I'd put the money towards RAM. Or maybe it's, I don't do any of that, but man, I do so many different BIM models, and my hard drive fills up super fast. Great, let's bump you to maybe a little bit bigger SSD. So really the kind of the way I look at it is, where do you put your money? What do you prioritize? Is try to make your biggest pain points go away, or address your largest, heaviest components, and or look at it as, what can I upgrade later and what needs to be upgraded now? To the point earlier about RAM is so expensive right now that if you decided, look, let's go with 64 gig and let's go with 128 later when it comes down in price, you're rolling the dice a little bit that it's going to come down in price. But there are some things that could be upgraded later. Same thing with longevity planning. If this is a machine, if you're the type that every time the warranty's up, you're going to roll it over in 3 years, yeah, you probably don't got to future-proof as far. But if you're like, man, I want to get 6 years out of this machine, you're probably going to want to build it a little more robust, put a little more in it than you think you need now, because 6 years from now, you're going to need more than you needed today. So kind of think about, you know, if I'm in a 3-year warranty, do I want to replace right at the end of the 3 year, or do I want to double that? And kind of build that into your plan. The faster you turn them over, the less you have to beef them out now. The longer you want it to last, the more you want to really make sure you future-proof that machine. We typically recommend somewhere between 3 and 5 years. You know, 3 years is more on the aggressive end. If you want a new computer as soon as it's out of warranty, you always want that in warranty computer. 3 years is great. Anything past 5 years, you're starting to get a little long. Things are going to break down a little more. 5 years is a pretty good run. Not that, I mean, we've got systems. We have a system that I was working on 2 months ago that I personally built in 2012, and the dude's still using it. So not that they don't last, but he's also using AutoCAD 2000. So he doesn't exactly upgrade his workflow. But anyway, not that they won't last that long, but that's typically what we recommend is keep it fresh, where you always have a good machine that's working well, and you don't get stuck in the spot where the machine dies and now you're in a scramble to get something. And if you are, let us know. We typically have stuff in stock. We try to keep laptops, desktops, our most popular models in stock on the shelf, ready to go, so that if you run into that situation, give us a call and we'll try to get you hooked up ASAP. So with that, I'm going to give Joe the floor now to chat about, once you have that computer and it's in your office, what do you do to make sure it's operating best?
Yeah, thanks, Bryson. So there's a few things that you can do once you get your laptop. Some of it's basic, like the power plan, making sure that it's set to high performance, or apparently some of them even have ultimate performance. But that will just keep everything running at the top speed that it can. It doesn't slow down to reserve battery or anything like that if you're on a laptop. The minimum processor state is, it's in advanced power settings, so it is a little bit more advanced than a beginner setting, but it's something that you can pay attention to. The third one isn't really something you can necessarily do a lot about, but cooling is incredibly important, especially when you're trying to run these machines at their, kind of maximum capacity. I would suggest, if you don't really have a choice in the cooling solution that's within the laptop, getting, like a lap pad, and even using that on your desktop can make a difference and increase airflow and increase the efficiency of the cooling system that you do have. And that in particular is important because I'm not sure how to say this. I think that CPU manufacturers don't necessarily broadcast this information or make it like super available, but there's a lot of built-in safety functionality in those, and one of the main ones involves temperature. And so if the temperature of your CPU gets above a certain amount, it will throttle down, and there's not a lot you can do about it. There is some that are sold without that built into it, which is what you kind of want to pay attention to, I guess is the point. Is just seeing kind of how that performs and what happens when you're really pushing it. Extreme memory profile, the next one, that basically is for RAM. It's to make sure that your RAM's functioning at the speed that it's advertised at. Getting a solid state drive, Bryson talked about this already, I don't know that there's really another choice at this point. Solid state or go home, basically, as far as I'm concerned. And like I said kind of earlier, those things can load up fast when you're working in Autodesk products. There's places that you get used to looking at, things you can delete that are okay to delete, stuff like that, but oftentimes they fill right back up. So I guess it's in here. So keeping your drivers updated on your laptop or desktop is probably the most important thing that's on here. That's going to keep your, system operating at its peak efficiency. It's going to keep updated with any kind of changes that might occur. And where I have seen that one in particular affect people is when they have, for whatever reason, not been on top of updating their drivers, and then Revit will just start to crash regularly. And it might even tell you it's crashing because of your video card or because your drivers aren't updated, and all you have to do is download and install the updated driver, and a lot of those issues will go away. The other thing I'll mention here, because I don't remember for sure if it's on the next sheet, is that if you have a NVIDIA graphics card, sometimes you do need to go into the NVIDIA settings, and it's right there. It is on the next slide. Thank you. It's the hardware acceleration, making sure that not only within Revit is hardware acceleration turned on, but using that NVIDIA control panel, you can tell your laptop or desktop, especially your laptop if you've got two different graphics cards in it, to only use the high performance graphic card when you're in Revit, and then it will no longer try to use anything else. That's one of the first things that I always do to make sure that again, things are just working as quickly and efficiently as possible. I guess the last thing on here about optimizing view settings, this one talks about turning off shadows and reflections and different things like that, which are, especially, shadows and doing like sun studies and stuff like that in Revit is going to just, by default, crank up the resource usage of your machine. So making sure that that's not defaulted to turn on is really important. And the other kind of side thing that I'll add in here is that when you're working in Revit, especially when you do anything in the background, Revit's processing a lot more probably than you would expect. And one of the things that it does is if you make a change in your model, it's going to update every single view in your model. And so if you have a bunch of like working section views that aren't on sheets that you're just kind of using to visualize things, it's going to update those too. And it's going to take, more time, more resources, more energy to do so. So kind of keeping those things under control when it comes to views is a good way to kind of reduce the resource intensiveness of Revit itself. The only other thing I can think of to add to this that's not on the list is just, kind of in general, take care of your laptop or your desktop. Make sure you're updating things, even if it's outside of a graphics card driver or whatever. It's not like a perfect analogy, but the one that I always use is it's kind of like getting an oil change in your car. You're not going to drive your car for 5 years and never get the oil change. And if you do, then the engine's going to seize up and your car is going to be totaled and you're not going to have a car anymore. So not updating the drivers isn't going to make your laptop seize up, but it's going to make it work very poorly. And it's just kind of that regular maintenance, regular care that you can give to that, making sure that, you're just on top of things and that will be very beneficial for anyone, but especially can keep your newer machine running better for longer. So
Definitely. The number one killer of mobile machines, of laptops, is just, you talked a little bit about the care and maintenance of the drivers, but what usually kills it is getting full of dust, taken to a job site, drug through the mud. So take a minute and blow your fans out, especially if you're like the type that goes on job sites and you're around dust a lot. Take an air can, spray those fans out in the back, spray the lint out. Just make sure that not only do you keep the inside maintained, but make sure it can still cool. Spray those fans out, wipe it off, get the Diet Coke out of the keyboard. You'll be good to go. Well, this really opens up Q&A. Jared, how do you deal with dust in a laptop? So really, first and foremost, some laptops are very, very large pains in the behind to pull apart, and I would not recommend doing that. There are some in the HP lineup where the back just slides off. Those type are a lot easier to clean, but by and large, you're just trying to, first and foremost, spray the dust and lint and everything out of it. So those little air cans, compressed air cans that you can get from wherever, from Walmart or Staples or what have you. In fact, one of these right here. If you just spray out that, stick a little hose on, spray out all the fans, try to get as much dust out of it as possible. If you have a type that the back slides off of that exposes the fans, you could really hose those things out and keep them clean. I would avoid using, if you have like an air compressor in the garage, those do a really good job of blowing air out, unless you have a filter on it that filters water out. There is a certain amount of air in or water in those, and you can introduce water into your laptop or your desktop that you don't want to do. So just be careful with using like shop air if you've got one in your garage or whatever. But really, it comes down to spraying the dust out of it, spray the junk out of it. Same thing with the keyboard. Spray the keyboard out. When you wipe the screen, use either screen-safe wipes. They say not to use Windex and some of those more abrasive chemicals. Even just sometimes water and a microfiber rag to keep that screen wiped out. But really, what it comes down to is just keeping stuff out of the fans. It like Joe talked about, it really comes down to keeping that laptop cool. And the more junk you can keep out of it, run it on those cool pads. That's going to be the biggest killer, is going to be dust and junk inside the fans that makes it so it can't cool and it overheats. Jared also asked earlier a question about what talking points do you have when requesting new hardware. Management typically only looks at the price, not the efficiency gained. So looking at this, from an end user, my computer sucks, I need a new one. How do I convince my boss I need a new one? Kind of seems like the general of that question. That's a great question. And what you got to get them to see is the ROI of wasted time. So if it takes you twice as long to do a task, they're paying you twice as much to do it, right? So if you can get twice as much work done by having a faster machine, if you can kind of identify, I'm getting slowed down here, 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 and here. These are the things that are making it take significantly longer. A new computer would significantly speed these up, and I could be more efficient. And, of course, every person's going to want to hear that you could be more efficient and you're going to get more work done. So first and foremost is going to be kind of an ROI on I'm waiting on all sorts of things. And that's really where I would start to look at, is it time for a new computer, are common things that I do all the time slowing me down. If it's so bad that like every pick and click in AutoCAD or in Revit has a lag and it's click, wait, click, wait, click, wait. A, that's frustrating, and B, you'll probably get significantly more work done with less frustration if it's more smooth and streamlined. Or maybe it's you're taking on some new tasks. You were not doing rendering before and you're doing rendering now. And in order to support this, I need something new. You'll often run into like what's one I looked at the other day? It was a D3 Render. D3 Render does a really good job when you open it of saying like, here's your hardware and you're going to struggle because of this. Specifically GPU, guy was opening up, he had a laptop with a older RTX 1000 and it said, this is not going to cut it for workflows in D3. You might want to do something different or this is not going to be a great experience. So things like that. If you're getting pop-ups, errors, messages from applications saying this isn't compatible, that's another good place to show. But I mean, talking points is really going to be about how is it hampering what you do and how would a new one speed that up. Sean or Joe, you guys want to add anything to that?
I think you nailed it.
Yeah. Yep. You got another question that rolls in. Have you tested GPUs like the RTX 40s and 50 series versus the Quadro RTX A?
Yeah. So
in real Revit workflows, which not just benchmarking, but real workflows.
Yeah. So my favorite way to benchmark things when we're talking about Revit is an application called RFO Benchmark. So it's a tool that is written to harness Revit itself. It does a bunch of tasks. There's 16 or so different tasks that it does. It actually opens Revit in the background. It opens a Revit model. It spins it around. It does all sorts of tasks, and it will give you some numbers at the end of how fast it was able to complete these tasks. You can then compare that. That's going to give you some really good real world, because the hard part is benchmarking without real world numbers. If you take a machine and you put it in front of someone and say, was that faster? You could give someone double the horsepower. They're going to be like, yeah, I don't know, maybe. It's just sometimes hard for people to, there's a lot of two perspective into that felt slower, that felt faster. If you can benchmark with something like that. So yes, we have benchmark with RFO. If you take two cards, a Quadro card, let's pick, like, let's say we took a RTX 2000 Blackwell, that's going to match up against probably about a 5060. And what I'm comparing this to is like, just generic GPU benchmark numbers, like Passmark does scoring, where it'll give you a score. Those two are going to score about the same. You're going to see a little bit faster out of Revit from the 5060 than you would that Blackwell. So yes, even in real world, you're going to find that you're not going to have the crashing like you used to, and that processing power will shine through with Revit, and you'll have similar. Now, if you took and said, give me a RTX 4000 Blackwell and a 5060 or something like that, and you're not talking about two cards that are a card that's double the cost of the other, that's where you'll start to see that Quadro card really starting to shine. But if you go dollar for dollar, they're going to be very similar performers. Like I said, we just haven't seen the crashing like we used to. So if you want to compare, if you've got some systems that you want to see, RFO Benchmark is the very best. There's nothing better for comparing Revit next to each other than RFO. Joe, have you run into any other benchmarkers that you like?
No, actually, I've been nodding my head along this whole time because RFO is definitely the best one. I mean, there's other ones that are out there for sure, but yeah, not to get too dorky, but Revit Forum is one of like my most highly used resources as a BIM manager or even just a Revit user.
Yeah.
It's better than the Autodesk forums, and the guy who invented or created, not invented, I guess he coded, I don't know, whatever word you would use. His name is Gordon Price. He's like an administrator on Revit forums, and I've never met him personally, but I feel like we're best friends because I've read so many things that he's posted on there, and he just he's just really, he really gets it. Like he gets kind of the whole system, the system as a whole. You know, he's not looking at one specific thing or another specific thing. It's kind of how do all of these pieces work together, and what can it do? And I think that his RFO benchmarking solution, it doesn't just like get into your computer and crank everything up to a 10 and then see what it can see. It's doing real Revit tasks. It's saving, and I can't remember all the different stuff it does, but it's doing real workflow tasks that you would most likely encounter over the course of a month or a year or whatever as you're a Revit user. So that's my favorite. And the last time that I tested laptops, when I was alluding to that temperature thing with the CPU, I used RFO benchmark. So
the one piece I would add, the caveat is, so like you talked about a stress test where it puts it to the very max and sees, this doesn't do that. It does real world tasks. So the one maybe downside to RFO is if you have two extremely capable systems, they're going to spit out a very similar number because you've reached kind of that plateau of, right? If you had a machine with 256 gigs of RAM and 1,000 gigs of RAM, they're going to score about the same in RFO because you've reached the peak of what it can do. So don't be terribly shocked if you take two really high-end systems and they score the same. You've probably seen that before, Joe, that if they max it out, you may not see a huge difference.
Yeah, I agree with that.
Awesome. I'm not seeing any additional questions there, Bryson. You want to just advance the slide?
You bet.
Yeah, so just wanted to thank everybody for jumping on here, especially Bryson and Joe, who carry the bulk of this, and those that are attending. If you have any questions or need anything from either of us, here's our contact info. You can reach us at anytime. You got info@prosoftnet.com and info@BIMTM.com. Makes it quite easy to remember those. So, but again, just appreciative of everyone's time, and look forward to the next one we do.
Definitely. Yeah, I'll just echo what Sean said there, that if you got any questions about hardware, you got something immediately, you want to know about something in the future, reach out. We'd be happy to chat about services that we have, talk through models, send you quotes. We're here for whatever hardware needs you have.
Awesome. Well, again, thanks, guys. Thanks, everybody, and enjoy your weekend.
Thanks, everybody.
Bye.